Hello and greetings to you all. My name is Sahil and I'm a technical marketing engineer within NetBrain. Today we will explore preventing failover failures with NetBrain using no-code automation. I have used HSRP an example for this video, but rest assured the same concepts can be applied across all types of failovers in a network, such as WAN links, firewalls, or critical applications to ensure a seamless failover function. Critical networks are always designed with redundancy, and monitoring failover pairs is one of the top IT operations job. In case of a faulty failover, critical applications may be impacted, resulting in degraded user experience or severe outages. Failovers may fail due to several reasons, such as inconsistent changes, a faulty link, or maybe misconfiguration, which is why a standard practice of IT operations involve running continuous checks to catch any such potential issues. This is a simple configuration with one of the interface which is put under HSRP. One of the devices was set as active and the other unit as the standby router. Now my failover monitoring procedure will involve certain routine checks, which are mostly done by either checking the syslogs or running some commands on the device CLI. On number one, I check if there is any failover event that happened by monitoring the HSRP state of both the devices. I'll also check if there is any priority change, which can indicate an interface down situation. And third, I check if there is any deviation of the HSRP config from the baseline. These checks are more or less enough for me to assess the health of my failover pair. I also have checks like the split brain or the failover event count check, which I can utilize. Let us see if we can use NetBrain to simplify the task for us. Under the intent panel, I have various folders which contain the intents I can use. For HSRP related checks, I have created the folder named Failover Intents. Let me select both the devices, and then I will proceed to create the intent for both these devices. Let's take a quick look at the logic behind this intent. So there are a total of 3 checks that we are running in this intent. One is the HSRP priority check, then the state check, and then we also have the config drift check. Now, how we run the priority and state check is quite similar. We extract the data from the device using the show standby brief command, and then we track the state and the priority of each interface. If any of the state or priority changes from the last known state, an alert is generated. And for the configuration drift check, I have used a pre-built parser to parse out the HSRP related config from the device. This configuration is stored as the baseline configuration when the intent was created. Now, each time I run this intent, the new configuration will be compared against the baseline configuration. And if any out of band change has happened on the device, that will be alerted to the user. I know we are now eager to see the intent in action. Let me just quickly run the intents. Post the execution of the intent, we'll get the results. I can see here that there are few alert messages. First, let's see the diagnosis tree to understand what happened with the intent. Here we can analyze that C8 or switch 1 had issues, and the issues were caused by the config drift check, which means that there is a deviation in the HSRP configuration that happened. The other switch seems to be fine. We can also analyze the alert messages by clicking on the message here. And if I view by device, I can see there is config drift detected on VLAN 300 and VLAN 400 for switch 1. Let's click the message. Now, if we want to see why the logic interpreted this as an alert, this is because the standby 1 track 1 shutdown is a new command that has been introduced to the HSRP configuration, which was earlier not present on the device. So if I minimize this window, on the map, we can see that config drift is detected on VLAN 300 and VLAN 400. One major problem with any automation is how to scale the checks and diagnostics that we created for a single device over maybe 100 or 1,000 similar devices in a network. With NetBrain, the scaling aspect is made very easy using the automation data tables. ADT is a collection of tables where each table contains assets important to your network. For example, the HSRP devices table that I have here has all my network-wide HSRP sites and the associated devices per virtual IP. I have associated the same intent that we executed with all these devices. Now I can use the same diagnostic logic for each row here. ADTs are also a good data source to create dashboards for gathering network insights, like this HSRP dashboard that we have created. The first widget here gives a quick overview of the device types and count. It is telling me I have 4 Cisco devices which are being tracked for any HSRP changes. And then the other one here helps me catch any state change or priority change which happened behind my back. I can see an incident did happen on 8th of September. I can also assess the config drifts related to HSRP on the track devices, and then this widget tracks the split brain situations happening for each day. This will help me quickly escalate the issues to my lab team to check for any faulty connections. NetBrain is quite flexible and allows me to create many different ADTs for assessing a variety of failovers that are critical for my network. Here I have the root ADT, which captures all failover types such as HSRP, firewalls, WAN links, etc. I'm also using ADTs for critical application tracking to check for redundant paths and if any failover that happened on them. Using all these ADTs and some more, here I have created a network-wide failover monitoring dashboard for my NOC team. This will help any NOC engineer to get a quick overview of failover states and any patterns that may be arising for critical events like WAN link flap or a firewall outage. Here I have included a critical application tracker widget, since the first thing that any engineer or customer wants to know is if any of the applications have been affected as a result of a failover device malfunctioning. NetBrain helped us to answer some critical questions about our network, like what is the current state of our failover pairs, how many failover events happened in the last week, is there any config mismatch between the failover pairs, or if there were any failover issues or split brains in my network. And the most important, does a similar problem exist anywhere else in the network? These checks can be designed once and then run afterwards in an automated and continuous fashion, which helps save time and resources. Thus, with NetBrain, we can get some significant business advantages, such as better resource management, assurance of uptime, and a single monitoring and diagnosis solution for network-wide issues. If you would like to learn more of NetBrain, you could join our power user trainings. These advanced trainings are available online and in-person modes at many cities across the globe and without any cost. The link is shared in the description box below. Also, if you have enjoyed this video, please hit the like button and subscribe to our channel. You could leave any feedbacks or queries below in the comment section. Thank you and have a great day ahead.